welcome everyone. Before we start, I'd like to ask you, how many of you are aware of or know of Bicep as a product? Pretty much everyone. Good, because we're going to talk quite a bit about Bicep today, and I didn't intend to cover too much about what Bicep actually is. But Bicep is a declarative language written by Microsoft, which lets us deploy Azure resources in a declarative way. It's basically the successor to ARM templates. So almost 3 years ago, Brendan Burns tweeted this tweet, and by that he also announced the first early alpha version of Bicep. When this happened, we were really excited. We started using it directly, and we soon realized that there were a few rough edges. Not because there is anything wrong with Bicep, but because it was alpha 0.1, so it was a really early release. So we started working with it, and one of our colleagues, Stefan Ivemo, wrote a few PowerShell scripts to make our everyday life a little bit easier when we were working with Bicep. And 6 months after the initial release of Bicep, Stefan released a PowerShell module called PS Bicep. The actual module on PowerShell Gallery is called Bicep, but the GitHub organization and repository is called PS Bicep. So Stefan released that module 6 months after the first version of Bicep. And today, roughly 2 years later, we are just shy of 1.5 million downloads on that module. And we've also managed to gather 103 stars on GitHub. So we are super happy about that. And today we are going to give you the story of how the module was born and how we got to this point. My name is Simon Wallin. I'm a Microsoft MVP and a Bicep Core maintainer. And with me, I have
your coworker, Emanuel Pa. I also work as a cloud consultant with Azure and Code. We both love PowerShell, and we work at Advania Sweden Knowledge Factory. We also code after work, and that's kind of how this module was born, you could say.
Yeah.
Before we get into the actual story, we would like to shout out our sponsors who are making this happen. Absolute massive thanks to everyone involved in making this conference a thing, and just thank you to everyone there.
All right, so let's get back to the module. In the very beginning of this module, we had a few simple commands. First off, we had the install and uninstall Bicep, which was actually the first reason or the first script that we wrote, because Bicep were released in nightly builds and they were released as GitHub releases, and you had to kind of download them and put them in the right place. And we were daily doing like, oh, have you tried this new feature in this daily build? Yeah, it works better than yesterday, but the thing from before, the day before yesterday was still there and so on. So we did a lot of like uninstalling and installing different daily builds of Bicep. So having the install and uninstall Bicep was just like a major quality of life thing. We also had two simple wrappers around the Bicep CLI. So we had invoke Bicep build, which is now build Bicep. And that was just a simple wrapper around the Bicep exe file. We also had a convert to Bicep, which was a simple wrapper around the Bicep decompile command, which could convert ARM templates back to Bicep. And then we had a command that created a new Bicep parameter file. At this time, we didn't have that functionality either in the VS Code extension or in the Bicep CLI. So we wrote a simple PowerShell script that built a template to an ARM template, parsed the JSON, and figured out how the parameter file was supposed to look. Calling the bicep.exe, and in the beginning we actually called the bicep.exe because we were developing this on Windows, and we were mainly using Windows, all of us. So calling the executable had some downsides and some hard problems, or not, some problems. First off, parsing output, as you know, is hard. We realized that any time the Bicep team would change their output, we might have to redesign our parser, which is not something we liked. We also had a problem that the Bicep CLI only supports files, or supported files. Today, there is a -- standard out parameter, so you can get the output as a string in standard output. But at the time, we had to point the CLI to a file. The file would generate another file. So we pointed to a Bicep file. The Bicep CLI would generate a JSON file, and we had to read content or get content on that JSON file to get the result. So we wanted to just get the output as a string, and also the whole shelling out experience. It felt a little bit dirty. It didn't feel native PowerShell-y, and also it had quite a lot of overhead because the whole spinning up a new process and loading all the assemblies and stuff into memory. If we do that a lot, it takes about a second, and if you have several templates you want to build, that actually adds up. So we decided to use Bicep Core. The Bicep source code is split up in a few smaller projects or part of Bicep. So we took a dependency on the source code of Bicep, which gave us the ability to have richer output. Today, we output in actual objects or PowerShell objects into the information stream. So when you get diagnostics from building a Bicep template, you will get rich objects in the information stream, which you can parse and do stuff with. We also had the ability to build strings because now we weren't limited to the parameters of the Bicep CLI. We could actually dive into the full features of the underlying Bicep engine, so to say. And this was a lot more fun. We opened up a lot of more new possibilities, and we had a lot of crazy ideas about what we potentially could do. So this really kindled the open source spirit within our team and within our small group of friends. Quite quickly, a lot of our friends started contributing to this on the spare time. We have a team chat, and we saw that our colleagues were chatting at the evenings and at the spare time, because this is a spare time project. It's not something that we do in our work roles. We do it as a spare time project. We quite quickly gained 8 contributors, so we had quite a few people helping out building the module. And we realized that we had external people. We had people we didn't actually know using the module, which was really fun. We also built Linux support because we realized that if we were going to use this in production, we were most likely going to run it on a Linux container in Azure Pipelines or GitHub Actions. So we decided to make sure all the features worked on all platforms. So life was really good, actually.
Until it wasn't. So pretty quickly, with everyone getting engaged and starting using our module, we realized we were encountering some issues. First of all, when Bicep was updating versions of their assemblies and their dependencies, that was kind of out of our control, because we wanted to keep up with Bicep and all the functions and methods and functionality they were implementing, so that we didn't have to implement it ourselves. That was the entire point of the project. We were also kind of just in their hands for what they were choosing to implement in terms of libraries from NuGet and everything there. And they did not know, or they did not care, and they were not obviously supposed to pay consideration to what we were doing. But PowerShell also has certain dependencies. So, for example, we early on encountered Newtonsoft JSON as a super popular NuGet package being used both in PowerShell for JSON conversion, convert to, convert from, but also in Bicep to convert the templates, the objects in Bicep to JSON like ARM templates. Except when they upgraded their version, PowerShell did not, and suddenly we could not even load our module anymore because PowerShell imports all assemblies into the same space, and we end up with issues if they do not work with each other, if there are different versions with the same one. So we had DLL Dependency hell. We had a PowerShell session where PowerShell itself uses Newtonsoft JSON version 12 at this point. I think that might have changed. And we were loading PS Bicep, our Bicep module, which in turn loaded Bicep as the source code, which in turn loaded all the dependencies, one of them being now, after a new version, Newtonsoft JSON version 13. Boom, explosions. And it was pretty bad. So we figured, what fix could we do for this? Maybe a Band-Aid. So we decided to take the source code and on the fly in our build script actually just change the Bicep source code to like downgrade the package and hope it worked. And that's obviously a sustainable solution. So we had it working again, and we were very happy, and we maybe
for a
didn't
short while.
forget about the issue, but we postponed it. We kept working on the features. Bam, there's another one. So we had a conflict with another module, and we were starting to realize that this was probably a larger problem since we were not in control of our own assemblies, our own dependencies. We had to take what Bicep was implementing, and we had to stick with it. So what do we do when an Azure PowerShell module, Azure Resources, was now conflicting with the Bicep assemblies? Well, we were annoyed, and the issue people were annoyed. And as the community was using our module more and more, we realized that this was a larger problem. So we were in dependency hell. And once more, this time, we were loading PS Bicep, another version later on, a couple of months. I think we had the Band-Aid before you had to rip it off. And that was loading Bicep, another version, which was loading, in this case, Microsoft Extensions primitives. We don't have to bother going into detail what it does, but Azure Resources also use this package, but a much lower version. So they were once more conflicting. So we went back a year earlier in time, where Rob Holt from the then PowerShell team had posted a fantastic article called Resolving PowerShell Module Assembly Dependency Conflicts, which is a lot of complicated words. And the article is even worse. It's fantastic, and it's super complicated as a concept. So Rob did a fantastic job on going through all the types of normal occurring scenarios where you have conflicts with like dependencies, and there's like one version of doing this fix in PowerShell 5 and below with .NET Framework, and there's other ways we can fix it in .NET Core or .NET and PowerShell 7 up. So one of the solutions that was suggested was to use a new feature called assembly load contexts for the conflict here. And what is that? Well, as it, from the sound of it, it is a context in which assemblies are loaded into. We have a few facts here. Well, first of all, it was introduced in .NET Core, now known as .NET. And we know that each assembly load context can only hold one version of an assembly. And PowerShell only uses one assembly load context. This is the default one. It's a static reference. If you want to point to it and do stuff with it and like look at it, you can do so using the code below. And you can find which assemblies are loaded into it and such. And there are also some stuff that we've been using to make this happen. But the crux of the issue is this. We can only load one version, and PowerShell can only load one version of each assembly. So the obvious thing to do was to create a new ALC for our module. A new assembly load context for us, where we would load everything we needed that would never conflict with anything else. Easy? Probably not. So we decided to implement a project called BicepNet, where we had a few goals. First of all, we needed to hide all the dependencies we were using from PowerShell, so that if we put them over here, PowerShell would never learn about them, and when we load our manifest saying that we need these dependencies, PowerShell will be like, what dependencies? I don't even find them. What are you doing? Like, were you asking me to look? I don't know. So after that, we obviously need to find them ourselves. So we needed to override or inject and modify the loading logic of our module. And here we created our own assembly load context. And finally, we needed to make sure that we never exposed any of the types from Bicep that we are using internally in BicepNet and the module to the user and the PowerShell session. Because as soon as PowerShell learns about these types and the DLLs and the assemblies and everything, we have just written a more complex solution for the same problem. So we needed to separate them and make sure that anytime we would use a type from Bicep and want to expose it to the user somehow, we would have to mirror it or model by it so that if we had a Bicep template, for example, we would create our own BicepNet template and export that one and map just the values. Because the only things that could pass out of our modules would be like strings, booleans, integers, common types. And this is kind of how it worked. So we had PowerShell and we had PS Bicep on the side, loaded as one module, and another module on the other side where PS Bicep loaded Bicep and an assembly X. The other module also loaded assembly X, and there was a conflict. So we would put BicepNet in between PS Bicep as two parts. We had BicepNet.ps, which was a PowerShell module written in C#, which in turn also handled all the resolving and the assembly load context creation. And that second part was BicepNet.core, which would be a wrapper for all the Bicep logic, all the functions. We kind of built an SDK for Bicep in C#, which our submodule was using in its own ALC. And this separated it so that PowerShell was happy because there were no conflicts. We would load all the assemblies into its default assembly load context, and we would load the ones we were using into another one. And this is kind of the final solution. So we had a module in PowerShell, using a module in C#, using the Bicep SDK that we wrote, using Bicep source code. So it wasn't super simple, and it took a while to figure it out. But that's kind of the current solution for the structure of the project. We have at the top the Bicep source code found at Azure Bicep, which we actually cloned down as part of the build and release stage into our BicepNet project, where we use a lot of the source code directly, depending on the projects and the actual unbuilt source code, to get access to their public methods and functionality exposed. And then we use that SDK, which we build in BicepNet.ps, which is a submodule used by our PowerShell module in PowerShell. And these are the GitHub repos that we can see above.
And this solution worked very well. And the blog post that Rob Holt wrote is now created as an article on Docs. And that article, actually, this screenshot is from that article. So we made the official PowerShell documentation, the article covering this problem and the solution based on Rob's blog post now links to our Bicep PowerShell module, and it also links to a great blog post that Emanuel wrote called Resolving PowerShell Module Conflicts, where he describes the problem and how we built our solution. And if you think this is an interesting topic, Emanuel has a session on Wednesday at 5, where he will deep dive into the whole assembly load context and the various way you can solve this problem, basically. So I really recommend you to attend to Emanuel's session on Wednesday. So where are we today? Today, we have full Bicep functionality. So everything you can do with the Bicep CLI, you can do with our module. We don't wrap the Bicep CLI anymore, but we depend on the same underlying source code. So we use Bicep, but we don't use the CLI. We load the assemblies directly into PowerShell. We are way faster than the CLI, mainly because we load the assemblies once and then we kind of keep them in memory since they are part of the module, and then we can like build a Bicep file or build several Bicep files over and over again. I'll show that in a demo in a while. We have a few extra features like working with parameter files, and also we have some new export commands. So we are able to programmatically point at a resource in Azure and generate the Bicep resource or Bicep template for that resource. That extra feature is implemented in the VS Code Bicep extension today, where you can use a feature called insert resource. Problem is that insert resource can't be used programmatically, and it only supports resources inside a resource group. And since we work a lot with Azure governance, we work a lot with RBAC, we work a lot with Azure policies, and we work with management group and subscriptions. So we need to be able to use this in all scopes. So our implementation supports, I hope, all scopes, at least all I've tested so far.
Put an issue if it doesn't.
Yeah, please put an issue if it doesn't. And we can also export child resources. So we can point at the management group and export everything in that management group. And we have rich output. We output all the diagnostic output from Bicep as object into the information stream. So you can pick that up and work with it. There are, however, a few breaking changes in the latest release. So that's why that release is the preview release. Since Bicep now requires .NET 7, we also require PowerShell 7.3. And that's all good so far. But the problem is that the GitHub Runner Images project, which is the images used in GitHub Actions and in Azure DevOps pipelines, are using PowerShell version 7.2 because that's a long-term support release, and they had some problems upgrading to 7.3, so they have chosen not to upgrade to 7.3. So if you're going to test our new preview release, which was released last week, you need to upgrade PowerShell inside of your runner if you're running it on hosted GitHub or Azure DevOps runners.
It's a good thing that none of our users are using the module in pipelines.
Exactly. We expect that there are quite a few people using it inside of pipelines, so that's why we have a pre-release, so we wouldn't break anyone, hopefully. It's just a few lines of code to install PowerShell. On Linux, it takes about 10 seconds, and on Windows, it takes about 15 seconds. So it's not that hard, but it's something you need to be aware of. Right, so let's look at it in reality. You know what? Thank you. So I'm here in my terminal, and I'm going to call the Bicep CLI. So I do Bicep build, I point it to a Bicep template, and I just do -- std out to get it as output in the terminal. So this works, but as you can see, it took 1.049 seconds, so it's fairly slow. It doesn't really matter when I use it interactively, but if I programmatically want to build tens or hundreds or even thousands of templates, it's going to take a lot of time. So what we are doing instead is that we are building Bicep and give it the parameter as string to get the same functionality. And if I do that, it takes 113 milliseconds. So it's approximately 10 times faster. We also have the functionality to do Bicep param, which is a new feature in version 0.18 of Bicep, where we can use Bicep parameter files and build them. So we have support for that as well. Now we have this Bicep export resource commandlet that I have a resource ID of a subscription, I believe, in the $resource ID variable. So I just pointed at the resource ID. Hopefully my internet will hold up here. And I will connect to Azure, I will get that resource, and I will generate the Bicep template for it and output that as a string. And here is that Bicep template.
Question.
Yes.
What kind of account are you using for the authentication right now?
Oh, that's a great question. So currently we are using the same authentication mechanism as Bicep are using. So you can point to or have a bicep config file where you can set credential precedence. And by default, we have a precedence of first PowerShell and then Azure CLI. So I'm currently signed in with the Azure PowerShell module. So the MCell libraries have a token, and we are just reusing that token, just like the Bicep executable is doing. So if I first have Azure PowerShell or if I have Azure CLI installed and I'm signed in, that just works out of the box for now. So if I want to export more than one resource, I can do export bicep child resource and point it to a parent resource ID, which in this case is a management group in Azure. And if I run this, it's going to take a little bit more time. And hopefully my internet still holds up. But what's going to happen here is that we are going to get the management group, and we're going to get all the resources in that management group, and for each resource, we're going to export it as a template. So if I do resources.count, you see that I now got 19 resources in 9.2 seconds. And if we scroll up to the export single resource, it took 1.8 seconds. So it doesn't scale linearly, but it actually scales.
Can you also save them as files instead of just strings?
Absolutely. If I do the same command, but instead of as string, it will output. I can give it an output directory, and it will output them each resource as a file. See if I can do this, and then I can also do the same thing, but this time I'm going to do another management group. So we do the same thing again. Last time we did it, it took 9 seconds, and now we're doing it again, and hopefully it takes 7 seconds. And if we look at the count, we can see that this time I had 135 resources in the management group. So what we have, what we're experiencing is that it doesn't take much longer whether you have 10 resources or 200 resources. If you have way more than that, we are going to get some throttling, and it's going to take some time. But it's fairly performant. We also have some functions where we can clear the Bicep module cache. So every time we use a module, so if you have a Bicep template using a module published in a registry or something, every time we build that, Bicep will kind of see if we have that module downloaded locally. If we don't, it will download it and put it in a cache. We can configure where to put that cache, but in our module, we can also clear that cache, so we can force that cache to be deleted and have every file re-downloaded, which is very useful in development scenarios. I have a Bicep file here, just as an example, where we have 2 parameters and 2 metadata entries. So here I have an author and a template version. We have created a parameter that, a commandlet that is get bicep metadata, which will parse this and output the metadata as an object. So here we can do get metadata, and I will get the template metadata. And this is very useful for when we want to publish templates to registries, because then we can have like the template version and the author and some links or some documentation or whatever we want, and we can just get the metadata and use that when we actually publish the template to a registry. Awesome, and I think the last command I want to show you is that we also have a test bicep file. So if you do test bicep file and point it to a bicep file, it will just return true or false whether the bicep file is valid or not. So it's a very simple like CI test. And we also have a bunch of other commands. If we do get command dash module, we can see that we have some a bunch of different.
We also have some experimental things that we thought might have been a good idea that the Bicep team have either disagreed with us on or simply not prioritized. So we have a command such as find Bicep module, which looks at an online registry that you point or based on a cache and finds all the modules available for you, which isn't in the CLI either.
Absolutely. So for the roadmap ahead, we are planning to make this bulk export really working. I want to be able to use this module to point to an Azure tenant and more or less export everything in that tenant or a management group and like recursively export everything so I can have a full export of an environment. I also want to have the ability to deploy to Azure. Today, we are kind of relying on Azure PowerShell or Azure CLI, but we have all the dependencies we need to actually be able to do the deployment ourselves. So we are thinking about or planning to have a deploy bicep command that will actually take a bicep file, deploy it in memory, and send it as a REST call to Azure to do the actual deployment. And I hope we can find a way to implement some kind of syntax tree functionality, because internally, Bicep have this program syntax object, which is similar to the PowerShell abstract syntax tree. So if I have a program syntax object, I can go through all the like child objects and modify a Bicep template. So I could basically insert a resource or modify a parameter or validate that a certain parameter has a certain description. So I would like to be able to export some kind of syntax tree, but we can't export the program syntax class because that's part of the Bicep DLLs, and then we have the whole assembly conflict problem once again. So we are experimenting on how we can do that in a suitable manner. We would very much appreciate any ideas on the matter. Our goals with the project is to keep up to date with the current release of Bicep. So whenever the Bicep teams release a new version, we are hoping to be able to release support for that version as soon as possible. This has been a very good learning experience, so we hope to keep learning. We have a lot of fun writing this, and we want the Bicep module to be a niche place or a place for niche features that doesn't fit into the Bicep proper project. If we can have a feature implemented in Bicep, that is of course what we want to do. We do absolutely not want to compete with the Bicep CLI. We want to be a complementing module for stuff that maybe are a bit too niche or doesn't like fit into the common goal of the Bicep CLI.
Some learnings.
Yeah, we have this meme. We finally found it after 15 years. The scroll of truth. Don't depend on someone else's source code. Yeah, we have found that it's
challenging.
Yeah, it's a bit challenging to depend on.
Especially when we are depending on a early release of a tool that keeps making breaking changes internally. It has been a journey to keep up with, to say the least. I think we've made at least 2 or 3 entire refactors of the entire code just to fit the way that Bicep builds things. And sometimes we can use the same way, even though they upgrade and change. And sometimes it just breaks entirely and we have to spend a week on figuring out what happened. So it's, I don't know, would you do it again?
I think I would absolutely do it again because it's a lot of fun, but I wouldn't recommend it
to anyone else of faint of heart.
Yeah, exactly. I wouldn't recommend it to anyone that wants the result, but if you want the journey or the learning experience or the challenge, it's great fun. We also realized that if we create a module and we have this small feature in it, and then suddenly someone else depends on that feature, and we have a hard time changing it. So the whole to ship is the shoes has been a new experience. So by that, does anyone have any questions? Glass clear. Awesome. Then I'll say thank you very much.
Thank you.